All right, today we are going to talk about hypothesis testing still, but 8.1 is kind of like the introduction to all hypothesis testing, most of it anyway. So there's just so much in that one section. Today is a lot lighter because we've really already covered some of what we need for this section in the overview. So in 8.2, we are specifically focusing on testing a claim about a proportion. So proportion only, not mean or anything else. So the proportion hypothesis test in the calculator, I've given you kind of the sequence here for how you would get to it. So we go to stat, tests, and then choice 5. Remember that when we did confidence intervals, we used Z when it was proportions, and we used T when it was means. And so that's why we use one prop Z test. So one proportion Z test is what that stands for. It's going to ask you to enter certain information, so it's important that we know what the symbols stand for. So P sub 0 is the value from the claim. So whatever the actual number is that they're talking about, so if they want you to test whether P is less than 0.7, then 0.7 would be your P sub 0. X is the number of successes. N is the sample size. And test type, like we talked about in 8.1, we either have left-tailed tests, if we're doing a less than, right-tailed, if we are doing a greater than, or two-tailed, which is when we have the not equal to. And the calculator will spit out at us the test statistic, the p-value, and our p-hat value. So remember, p-hat is the sample proportion that we're talking about. Okay, so we're going to look at just two examples, so much shorter notes here than in 8.1. In a study of 420,095 Danish cell phone users, 135 subjects developed brain cancer. Test the claim that such cancers are affected by cell phone use. So what I put in parentheses here, they don't always give you this type of information, but I wanted to do this example to make sure you're prepared to interpret these types of questions. So affected means that they cause a difference. It's not specifying greater than, less than, it's just saying different. And whenever we have something like that, that is a not equal to. So the claim is that cancers are affected, meaning that the rate is different for people who use cell phones than people who do not. We are going to use a 0.01 significance level, and then once we have our results, we'll decide if cell phone users should be worried about those results. So again, affected means it's making things different. So that means that our claim, and remember that on your homework, you do need to write all this stuff out in your problems. On the answers, it's not going to give you all of the pieces. It is going to give you, the final conclusion, and I'll give you maybe a few pieces along the way. But you need to make sure that you are, if you're doing a test of a claim, that you have to have, and it says test the claim right here, you have to have all these steps. And your 8.1 notes have all of those steps. So our claim is that P, because we're talking about proportions here, is different than the population proportion, which here it says the rate for people who don't use cell phones is 0.0340%. Now that's a percentage, so I need to move the decimal place 2 more spots over in order to have my p-value. I don't really need the other 0 on the end there. So remember that our null hypothesis always has an equal sign. So our null is going to be the equal to version of that, which obviously means that our alternative hypothesis, our H sub 1, is going to be the same as the claim. All right, once we have our null and our alternative, we're going to look at our alpha, which 0.01, so alpha equals 0.01. And we need to be able to find our test statistic based on that. What I'm going to end up doing is on example 1, I'm going to use the critical value method. And then in example 2, we'll use the p-value method, just so that way you've seen both. You do need to know how to do both. My suggestion is to rotate in your homework problems. Make sure you do some with the critical value and make sure you do some with the p-value, because you will be asked to do both on the quiz and possibly on the final exam. Okay, so since we're going to use the critical value method, we definitely need our test statistic. All right, so to find our test statistic, we will go to our calculator and use the key sequence I wrote up at the top. So I'm going to stop, scrolling over to tests. I'm choosing choice 5 for one prop z-test. And then I'm inputting the information that's right there in the problem. So I actually entered this, with the decimal points. It changed it to scientific notation, but 0.00034 is my p sub 0 value, because that's the value that's part of the claim. My x is the number of successes, which in this case is not really a success per se, but it's the number of people in that sample who developed brain cancer. So you can see here that's 135. The total sample size was 420,095, which I typed in there. The type of test is the not equal to, it's two-tailed. Color does not matter, so then scroll all the way down to calculate, press enter. And again, that gives us lots of information. It spits out, the first one is my test statistic. The second one is my p-value. The third one is the p-hat value. So in this case, since I'm using the critical value method, the only one I need from here is that z-value, that test statistic. So we'll write test statistic, and because it's a z-score, we're round to 2 decimal places, so negative 0.66. So test statistic, z equals negative 0.66. So when I am using the critical value method, I need to compare my test statistic to the critical values. So our critical values we find, and again, you don't have to draw the picture every time, I'm just doing that to illustrate for you. Since this is a two-tailed test, that means that I've got area on both sides that is making up the alpha. So since my alpha is 0.01, that means that there's 0.005 on both sides, because together, when I add those together, that gives me 0.01. So that means that I'm going to look at my areas here. Remember that the critical value method, I'm looking to see if my critical value falls in the rejection region. So there are 2 rejection regions here. But because my test statistic is negative, that means I really only care about this one, knowing what this value is right here. So to find this value, I'm going to do inverse norm of 0.005 with mean of 0 and standard deviation of 1, because we're always using a z-score here, which, where's my calculator? There we go. So, second distribution, inverse norm, 0.005 with 0 and 1. And that tells me negative 2.58. So, negative 2.58 is my critical value that I care about. So that means that in order for me to reject, I would need for this value, my test statistic, to be below negative 2.58, because only the values below are in this rejection region. So obviously negative 0.66 is not below negative 2.58. So that means that I cannot, so fail to reject is what we're going to say here. And that means, remember that we look to see if the claim includes equality, which it does not. This is a not equal to for the claim. So that means we're going to use support as opposed to warrant rejection. Because we failed to reject, that means there is not sufficient evidence. So we will say there is not sufficient evidence to support the claim that brain cancers are affected by cell phone use. And so, based on the results, should cell users be worried? We would say no, because we cannot support the claim that there is an effect there. All right. So just one more example, and as I said before, we're going to use the p-value method on this one. So make sure in your homework that you're rotating. In a KRC research poll, 1,002 adults were asked if they felt vulnerable to identity theft, and 531 responded yes. Use a 0.05 significance level to test the claim that the majority of adults feel vulnerable to identity theft. So, again, I'm trying to do some of the trickier ones. There are definitely some that are more straightforward in your homework, but here they're using this, the claim that the majority of adults, so they're not giving us an actual number, even though they really are. If you're taking a vote and you have to have a majority means that you have more than half. So this claim is saying that P is more than half, or P greater than 0.5. So that's our claim. Our null then would be that P is equal to 0.5. And our alternative matches the claim. Okay, they told us that we're using alpha equals 0.05. So since I'm going to use the p-value method, that means I don't really care about the test statistic in this case, because we're looking at our p-value size in comparison to our alpha. So we go to our calculator to run the test. So clear that, stat, tests, and choice 5 again. My p sub 0 this time is 0.5. My x value is 531. My n value was 1002. So again, just pulling these numbers straight from, excuse me, the values in the problem. So this one, we've got a right-tailed test because we're greater than. Scroll down to calculate. And that gives us our value. Now again, we're using the p-value method, so notice it's just plain p, not p hat. So my p-value, and I don't write p equals, I write p-value equals, because we don't want to confuse that with p, the proportion, the part that's in the claim. So in this case, our p-value is 0.0290. So 0.0290. And so remember that with p-value method, we're comparing the p-value to the alpha value. If the p-value is less than the alpha value, then that means that we're going to reject. So in this case, 0.029 is less than 0.05. So that means that we're going to reject our null hypothesis. So we make our final conclusion. Again, use that chart that's in 8.1. We need to look at whether our claim includes an equal sign, which it does not. So claim does not include equality, and we rejected. So that means that we will say there is sufficient evidence to support the claim that the majority of adults feel vulnerable, trouble speaking, to identity theft. And I always get people that ask, do I really have to write out all those sentences? Yes, you really, really do. This is not just me making up this, cumbersome activity for you. This is the way that you need to state hypothesis tests. So it's not just for this class, it's for any stats class that we use this very specific wording that is accepted for hypothesis testing. So yes, in your homework, you definitely need to write out your final conclusions if you want full credit. All right, hopefully that all makes sense, and make sure you ask and connect with me if you have any questions.